Okay, the next thing I want to talk about is simplifying radicals with products and quotients. Where'd it go? There it is. All right, so what I mean with radicals with products and quotients is I mean something like, if I look at the example that I have in the worksheet, I have 3 times the square root of 24. Okay, 3 times the square root of 24. So now this is a product because we're taking 3 and we're multiplying it by the square root of 24. Well, in the previous video, we simplified the square root of 24 already, but we can go through it again. So we make our list of squares. We go up to at least half of 24. So we have 4, 9, and 16. I know 16 doesn't work. I know 9 doesn't work. I know 4 does work, and 4 times 6 is going to work. So I'm going to rewrite my product with a radical as 3 times the square root of 4 times the square root of 6. Okay, and then just like we did in the previous video, we can simplify the square root of 4 to be the square root of 2. Or sorry, not the square root of 2, just 2. So we have 3 times 2 times the square root of 6. And then since this is a product, we want to take the 3 and the 2 and we just multiply them together. So any numbers that are on the outside of the radical, we just multiply together. So we end up with 6 times the square root of 6. Okay, so pretty much the same as what we just did in the previous video, except we just add this extra little step of having a number on the outside that we now have to multiply times whatever we simplify. Okay, so let's take a look at an example of a quotient this time. Quotient is just a fancy word for division. So in the worksheet we have the square root of 50 over 10. Okay, so now with the square root of 50, some of you might immediately recognize that, I think 25 is going to work, but if you don't, that's okay. Make our list of squares go up to at least half of 50. So we have 4, 9, 16, 25. Well, 25 is exactly half of 50, so that's a good thing because we know that 25 times 2 is 50. So that means we can basically eliminate everything else because this is the largest perfect square that divides 50 evenly. So I can write this as now the square root of 25 times the square root of 2 over 10. And then I can simplify the square root of 25 to be 5. So I'm going to have 5 times the square root of 2 over 10. I don't want to forget my equal sign there. And then since this is a quotient, and quotient means division, when I have 5 over 10, that's the same as saying 1/2, right? So basically, I'm going to simplify this to the square root of 2 over 2. And I didn't write the 1 where the 5 is because I don't need to, because 1 times the square root of 2 is still just the square root of 2. So when we simplify this one, we get the square root of 2 over 2. Okay, now there are some unique situations that we need to think about when we're dealing with quotients, and they are on your worksheet. And one of them is if we have 2 radicals in a fraction. So if we have something like the square root of 72 over the square root of 6. Okay, so when we have 2 radicals in a fraction, the neat thing about radicals is we can turn that into 1 radical. So we can say, hey, instead of having 2 radical symbols there, we can make it 1, and we can have 72 over 6 underneath. And then division allows us to say, 72 divided by 6 is 12, so this whole thing becomes the square root of 12. And then we want to go through the process of simplifying the square root of 12. Now, square root of 12 might be a little bit easier for you to recognize, but if not, make your list of numbers that are at least up to half of 12. So we have 4 and 9 are the only 2 perfect squares that are around half of 12, or up to half of 12, I should say. And I know that 9 doesn't go into 12 evenly, but I know 4 does, and I know it's 4 times 3. So I can rewrite this as the square root of 4 times the square root of 3. And then I can simplify the square root of 4 to be 2 times the square root of 3. Okay, so something that looks pretty tricky, the square root of 72 divided by the square root of 6 ends up being just 2 times the square root of 3. Okay, a couple of other scenarios that we need to look out for are if we have a product and a quotient mixed together. So in the case of a product and a quotient mixed together, we have a product in the numerator. Whoops, that's kind of ugly. We have a product in the numerator of a fraction over a radical in the denominator. We can do the exact same thing that we just did, but we just have to manage this 8. So this 8 is just going to kind of be along for the ride because it's multiplied. So I'm going to write it as 8 times. I'm going to create one radical, 75 over 15. And then I'm going to do the division that's on the inside of the radical. 75 divided by 15 is 5, so I have 8 times the square root of 5. And that's it. That's all I have to do, because there are no perfect squares that divide 5 evenly. Okay, and then the last one that I want to go over that's on the worksheet as well is, what if this is flipped around? What if we have a product in the denominator and a radical in the numerator? So in the case of the example on the worksheet, we have the square root of 48 over 3 times the square root of 8. Okay, so we're going to do the same thing that we just did, where we combine the two radicals into one. Now, in this case, that 3 being down in the denominator has been confusing in the past for some people. So what I'm going to do is I'm going to add that 1 that we didn't put in the one on the previous page. So we have 1 times the square root of 48 over 3 times the square root of 8. And when I do that, now I can see, hey, I have 1 over 3. So I have this fraction 1 over 3 times this whole radical 48 over 8. So if I just do the division, 48 divided by 8 is 6. So I have 1 over 3 times the square root of 6. And you could very easily stop there if you wanted to, and it would be a totally acceptable answer to have 1/3 times the square root of 6. But we can make that even a little bit simpler just by saying, hey, I'm going to now multiply 1 times the square root of 6. Well, anything times 1 is just itself, so I can write this as the square root of 6 over 3, and that's it. I'm done. All right, I hope this helps. If you still have questions, feel free to email me or find me during the office hours this week, or even post something in the discussion. That's a good way to get some help from me or also from some of your other classmates.